Good morning to you, class. I once again welcome you to this continuation of what I taught last week when we started the probability. We defined it and we saw some key terminologies which are used in probability, and we saw the calculation of probability and the scale. We saw also the scale of probability, which runs from 0 to 1 inclusive, or 0% to 100%. And we said that all positive fractions which don't exceed 1 are the probable answers of probability, and anything outside that scale we call it busting. For those, some of you who have ever played that, when you score more than what is required to finish up the game, you have busted. So when you get the answer above 1, you have busted. So it should be that. Now let us continue again with probability, and we start with what do we mean by an event. Much as last time we saw what is an event, but once again let me tell you that it is a subset. Is a subset of the given outcome set of interest or study. So if you have anything, it's given outcome set of study or interest, and you pull out some few, then that is an event. So we want to see the types of events. Number one is mutually exclusive events. Two events of the same experiment are said to be mutually exclusive if their respective events do not overlap. Means that if you perform an experiment and the two events they don't overlap, you can't have an intersection between the two, we say that they are termed as mutually exclusive. When the experiment is performed, events that are mutually exclusive cannot happen at the same time or cannot happen together. Let me give you an example. Like if you toss a coin, you cannot get the head and tail at the same time. You either get a head or a tail. You cannot get a head and a tail. So that means the probability of those two happening together is 0. And you can see it being drawn in the Venn diagram, whereby you get two separate events and there is nothing in common together. If you are male, you are male, and if you are female, you are female. Although some scientists, you see, they normally claim that there are some who have both sexes, but me, at my age, I have never seen any. Therefore, I can say that being a man and being a woman are mutually exclusive. So probability of A and B, which is equal to the probability of A intersection B, is also equal to 0. And it is a rule. One time I asked my mathematics teacher when he was teaching us about rules, and you ask him, but how or why? He will just tell you it is a rule. But the fact is, mutually exclusive events, they don't overlap, they don't have any overlap, they don't intersect, and therefore the probability of A intersection B is equal to 0. Think of two events. Think of any two events in your daily life which are mutually exclusive, and please add them in your notes. That let A be event this, and let B be event that. Those, and then term them mutually exclusive. Me, I have given you two scenarios. Examples: driving a vehicle in both manual and automatic transmission. You cannot drive a vehicle when you are using manual transmission and at the same time using automatic transmission. There are vehicles which have both manual and automatic. You just press a button and you drive it in whatever you want. But you cannot drive in both manual and automatic transmission. So those are mutually exclusive. And I've already told you, in rolling a die, the events getting even numbers and odd numbers would be mutually exclusive. Because if you get a 2, 4 or 6, if you get a 2, you cannot get a 5. So it is mutually exclusive. And being a man and at the same time a woman, I've already given that example. Then additional rule of mutually exclusive events. If events A and B are mutually exclusive events of an experiment, then probability of A or B, whenever in probability you find the word or, it means a union. And whenever you find the word and, it means intersection. So probability of A or B, which is equal to probability A union B, is equal to probability of A plus probability of B. And then you recall that probability of A and B is equal to, which is probability of A intersection B is equal to 0. So that is, that's a formula, that's a rule. So if you've known in a probability that the events you are talking about are mutually exclusive, that's the formula you are going to use. By the way, what in the probability, you should always be in position to categorize scenarios, because there's nobody who will tell you that this is mutually exclusive or whatever events which I'm going to talk about. It's up to you to see that these two events which they are talking about are mutually exclusive. We are going to see the dependent events and the independent events. So you categorize them according to what you have read. So if you read any scenarios and you've already categorized them as mutually exclusive, please just get the probability of A. Probability of A or B is you add the two probabilities of A and B. If it is the intersection, it is 0. So let me give you an example. In a group consisting of 40 men and 60 women, each was asked about whether or not they had attended Bobby Larry's. 25 of men and 20 of women had done so. Then if you ask you, find the probability that of men or women who had not attended Bobby Larry's. So being a man and being a woman are mutually exclusive. So that is categorically mutually exclusive. So those who had not attended, if you go by the previous statement, you'll find that the men, I'm saying, and I've written that let probability of A be the probability of men not attended Bobby Larry's. The men, the total number was 40. Those who attended were 25. So that means out of 100, because the total number of people is 100, and that is the total possible outcomes. They are 100. And if you recall our formula of calculating probability, that probability of any event is equal to number in E, that is number of events, over number over the total possible outcomes. So you will get the 40 subtract of the 25 who attended, you will get 15 who are out of 100, and those are men who did not attend. That's the probability. And let B probability B be the probability of women not attended Bobby Larry's. That means the total number of women were 60, subtract of the 20 who attended, you remain with the 40 women who did not attend out of 100. Therefore, probability of A or B, which is equal to probability of A plus B, is equal to 15 over 100 plus 40 over 100, which is 55 over 100, and is equal to 0.55. So that would be the answer if I had given it to you as something to work. So we go to independent events. We have seen the mutually exclusive. Mutually exclusive, those events which cannot happen at the same time. Independent events, these occur when one outcome is known to have no effect on another outcome, i.e., occurrence or non-occurrence of one of the events will in no way affect occurrence or non-occurrence of the other. So that means one event occurring or not occurring does not affect the other one to occur or not to occur. So that is, these events, they are not mutually exclusive, but one happening is not influenced but by the other, but they can both happen. Although the probability of their happening is very, very minimal, but is not 0. Let me give you an example. A manager getting promoted, and on the same day, his wife giving birth, on the day when the manager is promoted. Those are two different scenarios. Let us say probability A is the manager, probability A, the manager getting promoted, and the probability B, the wife giving birth. Those are two different scenarios. They are independent, but they are not mutually exclusive. The manager can get promoted on the very day when his wife gives birth. So those are independent, not mutually exclusive. Delivering on time by any supplier and the supplier's account not paid. So delivering on time is a different scenario, and the supplier's account being paid or not paid is another. So these are independent events. So that means they can happen together, although they are happening is very minimal, but not mutually exclusive. So those are independent. No, if events A and B are independent, their occurrence together is very minimal, but not zero. Hence, such events are not mutually exclusive. They can happen together, although their probability of happening together is very small. So, multiplication rule of independent events. If you've got a scenario of independent events, the probability of A and B, which is the probability of A intersection B. So that means you get the Venn diagram, you get the intersection bit, you divide it by the entire universal set of the diagram, is given by probability of A times probability of B. That's the formula, and it's a rule. So if two events, probability of A and B, and they are independent, you just get the probability of A, multiply it by the probability of B, you will get the probability of the intersection. Whereas for mutually exclusive, we say it is 0. Then the additional rule of independent events. Probability of A or B, which is the probability of A union B, is equal to probability of A plus probability of B minus, note that those signs are not equal. Minus. Please note that it's a minus probability of A times probability of B, which is given down there in the summary that it is equal to probability of A plus probability of B minus.
It's a minus.
Minus probability of A intersection B. So note that it is minus. Note, we remove probability of A intersection B to avoid double counting, since both A and B events can happen together. So double counting, you people, I know you are BBS students and you have done some accounting, because the intersection bit on independent events is found for both A and B. If you don't remove it on one side, you will get what is we call double counting. And even if you just add it like that, you may get something which is even supersedes 1. And you know that the maximum number, unit in the probability is 1. So that means we remove the 1 intersection, probability of A intersection B. We remove it from the probability of A plus probability of B. Example. The probability of an assembly line of production process failing is 0.03, and the probability of having delayed raw materials order is 0.1. Those two events are known to be independent of each other. A. Find the probability of an assembly line failing and having delayed raw materials, and means intersection. And B. Find the probability of an assembly line failing or having delayed raw materials order. So that is food for thought for you to calculate. And please, when I tell you to calculate, I will tell you to submit in the future, but not now. So that is for you to practice and show that you have perceived independent events. So let us go to dependent events. if two events are such that the outcome of one affects the probability of the outcome of the other, then the probability of the second event to occur is said to be dependent on the outcome of the first. So that means the outcome of the second event is dependent on, the outcome of the second event, yes, is dependent of what happened first. So those are dependent. For example, in production, we have yield, say, of maize, and then fertilizer application. So yield is dependent on fertilizer application, or yield is dependent on weather, climate. So that means in order to have more yield, you may be required to apply more fertilizer. So those are dependent events. Example here, from a group of 10 people, 5 of whom are men and 5 are women. So the probability of selecting a man is 5 out of 10, which is 0.5. And likewise, the probability of selecting a woman is 5 out of 10, which is 0.5. If a second person is selected from the remaining 9 people, the probability will depend on the outcome of the first selection. So if you select a second person from the group of 10, 5 men and 5 women, that will be dependent on what you selected first. Example, if you selected a man first, that means out of the 5 men, there remain 4 men. So in selecting the second man, you will have 4 men out of a total of 9 people. And the probability of selecting a woman, because the women are, so provided the first one selected was a man, means that women are still 5. So that means the probability will be 5 over 9. And that is represented down there by probability man, means the probability of selecting a man, provided the first one selected was a man, is 4 over 9. And the probability of selecting a woman, provided the first one selected was a man, is 5 over 9. Now, if a woman is selected first, and you want to select a man, provided the first one selected was a woman, it is represented by that inequality there, that probability of selecting a man / a woman, means that probability of selecting a second person, a man, provided the first one selected was a woman, means it is the men are still 5 out of the total of 9, because when you select one, the total remains 9. And the probability of selecting a woman, provided the first one selected was a woman, is equal to 4 over 9. Because after selecting a woman, there remains 4 women out of the total of 9. Conditional probabilities. Probability of B/A, we normally explain it as the probability that B occurs given that A has already happened. So means the probability of B occurring provided the first event that occurred was A. So probability B/A is the probability that B occurs given that A has already happened. What about probability of A/B? That one you will feel it in your notes, since you have known what is up there. And what I want to ask you, do you think the probability of B/A is the same as probability of A/B? Are they equal? Or is it the inverse? Probability of B/A is the inverse of probability of A/B. That one I rule it out, because if it is the probability of B/A, the probability of selecting B, so long as you have selected A first, is equal to 4 over 9. You can't say the probability of selecting A, provided you selected B first, is 9 over 4. That will have exceeded 1. So that is not. We shall see the calculation in the near coming time. Multiplication rule of dependent events. Probability of A and B, which is the probability of A intersection B, I've already told you, and means intersection is equal to probability of A times probability of B slash A, or probability of A and B is equal to probability of A intersection B and is equal to probability of B times probability of A slash B. I want you to take a note that when you use probability of A, you multiply it by the probability of B slash A, means you multiply it by the probability of B happening provided A happened first. And if you have used probability of B, you multiply it by the probability of A happening provided that event B happened first. So these two, B slash A and A slash B, are different probabilities. And therefore you should take a note, but the intersection which they measure is the same. So that means, as you are going to sit down there, the probability of A times probability of B slash A is the same as probability of B times probability of A slash B. So because they are both measuring the intersections. So Bayes' theorem. You will go to the statistics books, any statistics books, and read about Bayes' theorem. Bayes was a mathematician who came up with this, but you should put in the words and the nitty-gritty of what was he talking about, his assumptions and the like. My work here, as I told you earlier, is I'm a lecturer and I'm just lecturing you, but the bulk of the work you have also to go and read. Go and read about Bayes' theorem in any statistics book which you'll find in the library, or you Google and you ask Google about Bayes' theorem. So I've told you up that the probability of A intersection B is equal to probability of A times probability of B slash A, or probability of A intersection B is equal to probability of B times probability of A slash B. So these two, probability of A, since they are measuring intersection, are equal. Probability of A times probability of B slash A is the same as probability of B times probability A slash B. And if you have that one, and you are given probability A, probability of B slash A, and so on and so forth, you can calculate and find out and get the unknown using those two inequalities. For example, if you want to find probability of A slash B, you will get the intersection bit, which is the other side, probability of A times probability of B slash B over probability of B, which is the same as probability of A intersection B divided by probability of B. Likewise, if you want to find the probability of B slash A, you just get the probability of B times probability of A slash B, divide the whole of that by probability of A, which is the probability of the intersection divided by probability of A. Additional rule of dependent events. This uses the general rule of the general additional rule of probability, which goes that probability of A or B is the you are measuring the union is equal to probability of A plus probability of B minus probability of A intersection B. In mutually exclusive events, it remains probability of A plus probability of B because the probability of A intersection B is equal to 0. But here, for dependent events and for independent events, the probability of A intersection B is not 0. And I think for dependent events, the probability of A intersection B is big because one affecting the other is very high. So that means you can the intersection bit of it you can substitute it by probability of A times probability of B slash B, or probability B times probability A slash B, which we have already seen up there. So that is the additional rule of dependent events. Let us see an example. If the probability of having high yield is 0.8, the probability of having good weather is 0.5. And the probability of having high yield given good weather is 0.9. That is now the conditional probability. And you are asked to calculate the following probabilities: that there was good weather given high yield. 2, that there was high yield and good weather. Normally 3, what is the probability that there was high yield and good weather? What is the probability that there was high yield and good weather? So those one, that example is yours. It's not mine, it's yours, to try and conceptualize what I've given you up there and see whether you've got it.